Look up. On a clear day, you see it. A brilliant, warm presence in our sky. We call it the sun. But what is it really? It's not just a big lamp. The sun is a star. It is our star, the closest one to us in the vast, dark expanse of the cosmos. It sits at the very center of our solar system, a gravitational anchor holding everything in its place. All the planets, including our own Earth, are on a perpetual journey around it. This celestial body is the source of the light that illuminates our days, and the warmth that makes our world habitable. Without it, life as we know it simply wouldn't exist on this pale blue dot. The sun might seem special to us, and in many ways, it is. It's our life giver, our daytime companion. But in the grand cosmic scheme of things, it's a rather ordinary star. It's what astronomers call a yellow dwarf. There are stars out there that are hundreds of times bigger, and others that are much smaller. There are stars that burn hotter and bluer, and others that are cooler and redder. Our sun is in a stable, middle-aged phase of its life, steadily burning its fuel. It has been doing this for about 4.6 billion years, and it will continue to do so 4 billions more. It's a constant, reliable presence in a universe filled with change. If you could travel through space and look at our galaxy, the Milky Way, you would see billions upon billions of stars. Each one is a distant sun to some other corner of the cosmos. Our sun is just one of these countless points of light, located in a quiet suburban arm of our spiral galaxy. Yet, its proximity to us gives us a unique opportunity. We can study it in incredible detail, a privilege we don't have with any other star. By understanding our sun, we learn about all stars. It's our local laboratory for exploring the fundamental processes that govern the entire universe. A Rosetta Stone for deciphering the cosmos. So let's embark on a journey. A journey not across space, but deep inside this familiar celestial object. What's going on in there? What is the sun made of? It looks like a perfect, smooth ball of light from our vantage point 93 million miles away, but it is a dynamic, complex, and layered world. Peeling back its layers reveals a place of unimaginable temperatures and pressures. It is a place where matter behaves in ways we can barely comprehend. This is the story of what lies beneath that brilliant surface, a voyage into the heart of a star. Imagine peeling the sun like an onion. You would find it has distinct layers, each with its own job to do. Let's start from the outside and work our way in. The visible surface we see is called the photosphere. This is where sunlight is emitted. Above it are 2 more layers of the sun's atmosphere, the chromosphere and the magnificent corona. The corona is a wispy, super hot halo of plasma that we can only see during a total solar eclipse. But the real action, the true engine of the sun, lies deep beneath these outer shells, hidden from our direct view. This is the sun's interior, a realm of extreme physics. Below the surface, we first encounter the convective zone. This region makes up about the outer 30% of the sun's interior. Think of it like a giant pot of boiling water. Hot plasma, which is a gas of charged particles, rises from the hotter depths below. As it reaches the surface, it cools down and then sinks back down again. This constant churning motion, called convection, creates huge circular currents. These currents are what transport energy towards the surface, and they are responsible for many of the features we see, like the granular patterns on the photosphere. It's a turbulent, roiling sea of superheated gas. Deeper still, we reach the radiative zone. This is a vast, dense layer that sits between the core and the convective zone. Here, energy moves in a very different way. It doesn't travel in big, churning currents. Instead, it travels as tiny packets of light called photons. A single photon, created in the core, begins a long and tortuous journey through this zone. It travels a short distance, gets absorbed by an atom, and then is re-emitted in a random direction. This process happens over and over again. It can take a single photon hundreds of thousands of years to stagger its way through the radiative zone. It's an incredibly slow and random walk for light. Finally, we arrive at the very heart of the sun, the core. This is the powerhouse. The core is an unimaginably extreme environment. It's incredibly dense, about 10 times denser than lead, and the temperature soars to a staggering 15 million degrees Celsius. The pressure is immense, over 200 billion times the pressure we feel on Earth's surface. It is only in this cosmic furnace, under these crushing conditions, that the sun's ultimate secret is revealed. This is where the energy that powers our entire solar system is born. The core is where the magic of nuclear fusion happens, the process that makes the sun shine. So, what is the sun actually made of? It's not made of rock or fire in the way we think of it on Earth. The sun is a gigantic ball of gas, or more accurately, plasma. The two main ingredients are the simplest and most abundant elements in the entire universe: hydrogen and helium. About 74% of the sun's mass is hydrogen, and about 24% is helium. The remaining small fraction is a mixture of other elements like oxygen, carbon, and iron, which astronomers collectively call metals. It's this vast reservoir of hydrogen that serves as the primary fuel for the sun's incredible energy output. This fuel is consumed in the core through a process called nuclear fusion. It's a cosmic alchemy. The intense pressure and heat in the core are so extreme that they force hydrogen atoms to overcome their natural repulsion and slam together. When they collide with enough force, they fuse to create a new, heavier element: helium. This isn't a simple one-step process, it's a chain of reactions. But the end result is the same. 4 hydrogen nuclei are transformed into one helium nucleus. This fundamental transformation is the engine that has powered our star for billions of years. Now here's the most important part of this story. When 4 hydrogen nuclei fuse into one helium nucleus, something amazing happens. The resulting helium nucleus has slightly less mass than the 4 original hydrogen nuclei combined. That tiny bit of missing mass hasn't just vanished. It has been converted into a tremendous amount of pure energy, following Albert Einstein's famous equation, E equals mc squared. Even a minuscule amount of mass can be transformed into a colossal amount of energy, because the speed of light squared is an enormous number. This is the source of all the sun's light and heat. Every single second, the sun's core converts about 600 million tons of hydrogen into helium. In doing so, it transforms about 4 million tons of matter into pure energy. This energy, born in the core, begins its long journey outwards. It travels through the radiative zone as photons, and is then carried by the churning currents of the convective zone to the surface. From there, it radiates out into space in all directions. A tiny fraction of that energy embarks on an 8-minute journey across 93 million miles to reach our planet, providing the light and warmth that are absolutely essential for life. Understanding the sun is not just an academic exercise for astronomers. It is fundamentally important for our survival and our future here on Earth. The sun's energy drives our planet's climate and weather systems. It powers the water cycle, creates winds, and dictates the temperature of our oceans and our atmosphere. Without the constant stream of solar energy, Earth would be a frozen, lifeless rock. By studying the sun, we can better understand and predict its behavior, including solar flares and other space weather events that can impact our technology, from satellites and GPS to power grids on the ground. The sun is the ultimate source of almost all energy on Earth. The light it provides is captured by plants through photosynthesis, which forms the very base of the food chain that sustains nearly all life. The fossil fuels we burn, like coal and oil, are essentially stores of ancient sunlight, captured by organisms millions of years ago. As we look towards a more sustainable future, we are learning to harness the sun's power more directly through solar panels. Understanding our star helps us to better utilize its immense and clean energy, paving the way for a brighter future for our civilization. Furthermore, studying our sun gives us a unique window into the lives of all other stars. Because it is so close, we can observe its processes in exquisite detail. We can see its sunspots, watch its solar flares erupt, and map its magnetic fields. This knowledge helps us build and test models that explain how other stars are born, how they live, and how they die. The sun is our benchmark, our reference point for understanding the billions of other stars that populate our galaxy and the universe beyond. It teaches us about the fundamental physics of plasma, gravity, and nuclear reactions. In the end, the story of the sun is our story. We are, as the saying goes, stardust. The very elements in our bodies, heavier than hydrogen and helium, were forged in the hearts of stars that lived and died long before our sun was born. By looking at the sun, we are looking at the same kind of celestial engine that created the building blocks of our world and of ourselves. It connects us to the grand cosmic narrative. Learning what's inside the sun is more than just science. It's about understanding our place in the universe and appreciating the magnificent, life-giving star that makes our existence possible. At Fact Media, we believe curiosity fuels discovery. If you learned something new about the sun today, join us, subscribe, and stay curious.